number 13, drum roll, please. Ba-boom. However you want to do it. This is a shout out to Mrs. Ware's classes. I wanted to make sure I finished these videos as early as I could for you guys. My apologies for this delay, but I hope that you're still able to cram study tonight and make sure that you have a good, awesome test tomorrow for Mrs. Ware. Here we go. Number 13. Find the equation of the hyperbola that satisfies these conditions. So hyperbolas are these fractions where one is a positive and it's subtracting the other and it's set equal to 1. Order matters. Okay? So order matters will tell you whichever one this is, which is the positive, it will tell you whether it's looking up and down or left and right. Let's draw a quick sketch. We have the foci at positive and negative 5, 0. So here's the foci here and here. Okay, so this one's at 5, 0. This one's at negative 5, 0. And then we have the vertices at positive 4, 0 and negative 4, 0. Okay, remember that it goes through the vertices, and that focus acts like a shining light bulb, if you will, and it would look something like this. So we know it's going to be a horizontal, so that means it must have some positive x value. Okay, we can see because these are equidistantly 4 away from the center, and these are equidistantly 5 away from the center, it's easy and safe to assume that my center is in fact 0, 0. So now I know my h and k. Because it's not shifting left or right, we're just going to say x squared minus y squared, and we're going to set it equal to 1. Again, the reason why it's x squared listed first is because it is positive for the x because it's looking left and right. Okay? Order matters. Whichever one is positive, that's the one that it's going to be facing toward. Okay. Now, a is going to be this x term to the vertex, not to the foci or focus, it's just to the vertex. And we know that that's a positive 4. So we could say a is 4. Okay? We know c is 5, and we're going to have to use our equation so that we can get b, so that we know what to put underneath y. Okay, so a is x, so we're going to put 16 because it's 4 squared. Now we have to use this equation. Because this is subtraction, to solve for the c, we're going to add. Do the opposite. So it'd be a squared plus b squared. It doesn't matter the order because you're adding. So it'd be 25 is equal to 16, because that's 4 squared, plus b squared. So let's subtract this over. We get 9. Take the square root. b is 3. So whenever I plug this in as b squared, we're going to put it back to a 9. This is the equation because the positive x shows that it's looking left and right. Okay? This could be rewritten, just FYI, as negative y squared over 9 plus x squared over 16. And guess what, guys? Order matters. Otherwise, which one's positive? It's the same graph. Just because the y is listed first does not mean that it's going to be a vertical hyperbola. Keep that in mind, please, for the test tomorrow and the next day. The positive one will tell you which one it's looking at. Most likely we prefer this one. Most likely you will see that more common than the other one. Alright, last problem. Okay, so vertices. Alright, 0 plus and minus 6. So we have 0, 6 up here. Okay, and then we have 0, negative 6 down here. So that's where it's looking downward. Okay, these are vertices. So it goes through. And then you have the asymptotes of positive 1/2 x and negative 1/2 x. And it's, remember, from these asymptotes, which is y minus k equals plus or minus b over a x minus h. Okay, I can see that my rise over run, otherwise b is 1, and my run is a, which is 2. I can see just from this equation here that b is 1 and a is 2. So if b is 1 and a is 2, I can go to, I can look at as far as what is it going to be as far as my values over here in the standard form as far as what is it going to look like over here. Okay? So my center appears, because it was a 0, 6 and a 0, -6, which are equal distant away from the center, my center still appears to be that it's 0, 0. But because it's looking up and down, I'm going to put my positive y first and my negative x second. Okay? Alright, again, because it's a positive y, it shows that it's looking up and it's looking down. Now we just got to be careful and understand what b squared value will go here and what a squared value will go here, and we're done. That's a wrap. Okay, so it does look like it's a is 2, b is 1. Most people would put 1 and 4 and call it a day. But they would actually be wrong. And the reason why they would be wrong is because this came from a fraction that could have been reduced. It could have been 2/4, it could have been 3/6, it could have been 4/8, and now that changes how big A and B and whatnot are. Okay, so best advice I can give you is up and down is B. So we know it takes 6 units to get to that vertex or that vertex. So we can say that B is 6. Okay, so if B is 6, what's A? Okay, we know 1/2, otherwise B over A. I'm going to use that, and I'm going to plug in for B over here on this ratio. I'm going to plug in this 6 that I know from the graph. Otherwise, from this piece right here, that I can plug in a 6 to represent my B value. Cross multiply, we get A times 1 is A. Cross multiply, we get 12, so we could say A is 12. Which still makes sense, guys, because B over A, if I wrote it as 6 over 12, I still get this positive and negative 1/2. But notice how I cleverly used this ratio so that I could not only still keep this ratio true, but also I could find the true A and the true B. Okay, so B belongs with y, which is going to be 6 squared. And finally, let's see, the A. So rise over run. Let me make sure that I have this right. So rise over run is 1/2. So B is B is 1 and A is 2. So B over A is the same as, I just want to verify and make sure, 1/2. Yep. So it's going to be multiplied and A is going to be 12. So if A is 12, that means that that's going to go down here under x as 12 squared, and you get 144. Let me make sure that that is correct before we close this out and call it a day. Let me go through this one more time. Bear with me and follow me. Here we go. The B over A from the asymptotes is saying that it looks like B over A is equal to 1/2, saying that B is 1, A is 2. But because over here on the vertices, we saw that up and down it was 6 units, we put 6 units here for B. Okay? Because up and down is going to be a y value, otherwise B. So we have B over A is this 1/2, because it's rise over run, otherwise y over x. And if I cross multiply, sure enough, I do get A is 12. Okay, so we're going to get 12 squared. It belongs underneath x, and that is the answer for the last one.